Well, we're going to be working related rate problems, and we're going to start off with something pretty easy here. Um, and pretty much this setup that we're going to be working in this problem is how you work all the problems. Except sometimes it's kind of difficult to come up with actually this, especially if you're reading an actual word problem and they want you to either recall an equation or maybe construct your own equation. But what we're normally going to be doing here is they're going to be asking for example, dy over dt, or they may ask for dx over dt. And uh, and if so, well, that's what we're going to try to find. We'll be given some other stuff, like for example, in this problem here, we'll be given dx over dt and some x or y value. For this particular one here, we're given x is equal to 9. So we will, the framework here is you're given an equation. We want to find either dy over dt or dx over dt, and then we're given some information. Um, so what we're going to be doing here is we're going to take this equation and we are going to find dy over dt. So let's get started. So we're going to take the derivative of this with respect to t. Now I know there's no t in here. You don't see any t's in here, but well, you'll see. So the first thing we want to do, remember, when we take the derivative, we need to rewrite. We're going to have to rewrite this. And so because we have a square root of x down here in the denominator, I'm going to get this into exponential form. So this is raised to the 1/2 power because of this is a square root. And then we're going to take it up into the numerator like we always have done. And now we're going to take the derivative of this with respect to t. So what we do is, for example, the derivative of y is 1. Okay, but I don't write the 1 right here, right? And then when I take the derivative of y, if it's with respect to t, then I'm going to write dy over dt. Now, over here on the right hand side of the equal sign, you take the negative 1/2, you bring it out front, right? We're just taking the derivative of x here. Take the negative 1/2, bring it out front, subtract 1 from the exponent. So negative 1/2 minus 1 is negative 3/2. And then we take the derivative of x and we bring it out. And this is really like the chain rule, okay, as though these are two separate functions here. So you take the derivative of x, but then we have to write, we did that, we took the derivative of x, but then we must write dx over dt outside. We have to write dx over dt outside. Well, that's it right there. And then it's just a matter of plugging in the stuff that we're given and solve for what they ask for. So that's how this is going to always work. We take the derivative of each one of these variables with respect to t, and then once we get down to here, then we just literally plug in what they're giving us and solve for what they're asking. Now, because it's a negative 3/2 here, we want to take this down into the denominator. Right, so we have positive 3/2. So here we are. Now what we're going to do is we're going to go ahead and plug in everything that they gave us. Well, they said when x was 9, so we plugged 9 in for x. And when dx over dt is equal to 1, so we replace the dx over dt with a 1, and then we simply now just have to simplify. And of course, we simplify this down and you get negative 1/5. So simple enough.